Very good morning, sir. Today we are going to solve a problem on RL series circuit that is connected to AC supply. Take down this problem. An inductive coil draws a 10 amperes and dissipate 1000 watts when connected to a supply of 250 volts 50 hertz AC supply. Calculate first total impedance in Cartesian format. Next, second is current. Third one is phase angle. And fourth one is voltage across inductor and resistor. So these four things we need to calculate. So by studying the question here in the first line, so we'll try to know like this is only inductive coil. But actually speaking, so here they clearly mentioned in the fourth point, calculate voltage across inductor and resistor also. Inductive coil also there, and one more resistor also there. Okay, so somewhere around they will give this one. Okay, so if it is this is not given, it is purely a inductive load like that we can consider because inductive coil draws like that. But here you see total impedance also given. Inductive coil is given, total impedance also given. So impedance is the uh, formation of this resistance and inductance. So that also one clue. And another one is voltage across inductor and resistor. So that is also one clue. So easy. So by seeing this, by reading this particular problem, easily you can draw the circuit that is RL. So resistance is there, inductance is there. That is connected to 250 volts, 58 AC supply. So what are the given terms? So source voltage is given, that is 250 volts. Frequency is given, that is 50 hertz. Current draws, that is given, that is current is equal to 10 amperes. And another one is power. Power is given as 1000 watts. So that is also given. So now from the power we can easily calculate what is R because power dissipates. So power dissipates is what? 1000 watts. So power is equal to 1000 watts. So power is nothing but in terms of I squared R you can write. So I squared R is equal to, here why I squared R means why can't VI, P is equal to VI also is the voltage into current. But here it is I squared R because I is there. We need to find out what is R. So we can go for I squared R. So I squared R is equal to 1000 watts. So from this easily you can find out what is the resistance. R is equal to 1000 divided by I squared. So I squared is, I is nothing but 10. So 10 squared. So simplifying this, we'll get R as 10 ohms, resistance as 10 ohms. Now we need to find out what is impedance, Z. So Z is equal to V by I. So voltage also it is given. So 250 divided by I is also given. Okay. So I is what? 10. Okay. I is what? 10. Um, 10. So here power dissipated is always I squared R. Okay. Power dissipation. Say for example, one resistance is consuming that power. Means that is dissipated. Dissipation means some consume. So it is I squared R. Here power is I squared R. So here that is also, I forgot to say. Next is impedance. Z is equal to V by A. So V is given 250 divided by I is 10 amperes. So here Z is 25 ohms. So Z is 25 ohms and R is 10 ohms, means easily you can calculate what is XL square. So yeah, Z is equal to root of R squared plus XL squared, or in other terms we can write as Z squared is equal to R squared plus XL squared. So XL squared, if you take this side, XL squared is equal to Z squared minus R squared. So XL is equal to root of Z squared minus R squared. So from this easily you can calculate what is XL, that is inductive reactance. So inductive reactance XL is equal to Z. Z is what? 25 squared minus R squared. R squared is 10 squared. So if you simplify, substitute and simplify this, you will get the answer as 22.91 ohms XL, that is inductive reactance. You just tell in the comment whether you also got the same answer or not. Next, first one, what they asked? First, they asked what is the total impedance in Cartesian form. So Cartesian form is nothing but complex form. That's all. So Z is equal to R plus J into XL. So R is what we calculated as 10 ohms. 10 ohms. Next, the XL we calculated as 22.9. So 10 plus J into 22.91 ohms. Next, they want to calculate current I. So I is already we calculated. I is already given. So easily you can write. Okay. So I current draws 10 amperes. So same thing you can write. Current draws is 10 amperes. So that current is as. Next is phase angle. Phase angle is what? Cos phi. Cos phi is equal to R by Z by using the impedance triangle that we have seen in our previous formulations. So cos phi is equal to R by Z. So R is what? 10 divided by Z is what? Z is we calculated as 25 ohms. So 25 we need to substitute in. So cos phi is equal to 10 by 25 means phi is equal to cos inverse of. So easily you can calculate what is phase angle. That is phase angle phi is equal to 66.42 66 degree for 42 minutes. It's like okay. So next is voltage across the inductor. Voltage across the inductor. So voltage across inductor BL is equal to I into XL. So I is what? 10. XL we already calculated here. XL is 22.91 ohms. So XL also we just substitute and we can easily find out what is VL. 229.1. So next we need to find out what is the voltage across the resistor. So voltage that also asked in the problem. Voltage across the resistor. So VR is equal to I into R. So I is 10. Resistance R is also 10. We found out the R as 10 here. So just by substituting, we'll get the answer as 100 volts. So voltage across the resistor is 100 volts. So very simple, simple problem. Just direct formula substitution, you will get the answer. Okay. So this is how you need to solve the circuit for this RL series circuit connected to AC supply.